All right, last part. Looks like we are on number 40. So I'm looking at 8x to the 1/2 power. Remember that when we have a fractional exponent, 2 is the root, so this is a square root. Okay, and the key here is that all of 8x is to the 1/2 power, which means B is our answer. All of 8x should be under the radical. What we've seen in the past is something along the lines of that, where 8 was not under the radical, but x was. So notice the difference between these two problems. Okay, evaluating this, again, the denominator is the root, so the cube root of 125 is 5, and then 5 squared, so the numerator is what you're squaring or cubing, and 5 squared is 25. If you struggle with that, you can always use a calculator on that problem. 42, we're adding polynomials, which is the easy one. Really, the parentheses aren't even necessary here. But if I am just combining like terms, 3c squared plus c squared is 4c squared. Remember, when you're adding, you're changing the coefficient. When you're multiplying, like we did on the previous page, you're changing the exponents. And then negative 8c minus 8c is negative 16c. And 5 minus 6 is negative 1. So again, combining like terms. Now with 43, it's slightly different. We want to write the first polynomial and then distribute the negative sign to all three terms in that second polynomial. So it becomes negative t squared plus 2t minus 4. And now I'm going to combine like terms. So I have 9t squared minus t squared is 8t squared. I have 4t and 2t is 6t, and negative 6 minus 4 is negative 10. All right. Same thing with 44. We are going to have to distribute that negative, so 2a minus 5 minus 3a minus 1. So 2a minus 3a is negative a, and 5 minus 1 is negative 6. Sorry, negative 5 minus 1 is negative 6. Here it looks like we're just distributing. So 3 times 2 is 6. M squared times m to the second is m to the fourth, like bases add exponents. And then minus 3m to the third, m squared times m to the third. For 46, looks like we're just foiling or distributing. I'm going to use the FOIL method. So can we see that? Yep. FOIL. So my first 2n and n is 2n squared. My outer is 2n and positive 4, which is positive 8n. My I is negative 3 and n, so negative 3n. And then my last is negative 3 times 4, which is, whoops, negative 12. And then we can combine like terms. So I'm going to get 2n squared. 8n minus 3n is positive 5. Positive 5n, and then minus 12. 47. Solve. So at some point in any solve, we're going to have to use the zero product property, and we are ready to do that because this is b times b plus 17. So I set both parts equal to 0. This one's done, so one answer is 0, and then I subtract 17 from both sides, and I get b equals negative 17. So here are my two answers for 47. All right, last page. Probably got some factoring on here. Yep, first one. Whoa, why'd it go all yellow? See if I can fix that. Ooh, well, we'll just have to finish out, I think. Let me pause and see if I can get this fixed. All right, here we go. So we're going to factor m squared plus 13m plus 42. So again, I asked myself factors of 42 that add to give me 13. And so I'm going to start out with my binomials. And I know the signs are the same, and I know they're both positive. So m plus and m plus. All right, factors of 42. The first thing I think of is 6 and 7. And 6 and 7 is, oh, you can't see that, 6 and 7 is 13. So those are my factors. I can check it really quick. M times m is m squared, and then 6m and 7m is 13m, and 6 times 7 is 42. All right, 49, squaring a binomial. You can do this the shortcut way, or we can scribble out the 2 and write 3y minus 1 again, and then FOIL that. Let's practice the shortcut way. I square the first, so 9y squared. I multiply 3y, and negative 1 is negative 3y, and then I double that and I get negative 6y, and then 1 squared is 1. So again, if you wanted to, you could just scribble that out, write 3y minus 1, and then FOIL that, and you'll get the same answer. All right, number 50. So what we're going to do here is we got to use a distributive property. So I'm actually going to distribute this back to each of those terms. So I'm going to write, can you see? Yep. 3x times 4x squared minus 2x minus 7 plus 2 times 4x squared minus 2x minus 7. I'm going to distribute. Okay, and then I'm going to combine like terms, and I like to go with the biggest exponent first. So there's 12x cubed. I don't see any other 12x cubes, so I use that, and then that should be 6x squared. There we go. So 6x squared plus 8x, so negative 6 plus 8 is positive 2x squared. That takes care of those. Negative 21x minus 4x is negative 25x. That takes care of those, and minus 14. So that is my answer. All right. So here's our next one. 2x squared minus 5x minus 3. We got to factor this, and it has an a value. So we got to do first times last. 2 times 3 is 6. Okay. Factors of 6 that subtract to give me 5. That's 6 and 1. So that becomes temporary binomials. X signs are different. The bigger one will be negative, so plus, and x minus. Again, factors of 6 that subtract to give me 5 are 6 and 1. The bigger one needs to be negative. And then we're going to divide by our a value. Don't forget it equals 0. 1/2 does not reduce, so I'm going to take any denominator that's left and put it in front of its x. So 2x plus 1 is 1 factor. And then 6 divided by 3 is 2, so my other one is x minus 3. And that equals 0. And now I'm going to use the zero product property. So again, we just factored to get two binomials, and now we're using the zero product property, which is actually going to end up giving us essentially this, the x minus 3 and the x plus 1/2, but we'll just show you. So 2x plus 1 equals 0, x minus 3 equals 0. Subtract 1. Divide by 2, I get x equals negative 1/2, which is the opposite of what we had here. And then when I add 3 to both sides, I get x equals 3. So those are my two answers for 51. 52 is another FOIL problem. And actually, this is a difference. So there is not going to be a middle term. So we're going to get 4x squared. And again, if I FOIL it and go negative 10x plus 10x, the middle terms cancel out. And then minus 25, a difference of two squares. We worked on yesterday going from here to there. Okay. Factoring 53. Nothing's a perfect square, so I'm not doing anything like we did here or going backwards. And it doesn't have any variables in common, so I'm just going to take out a GCF of 12. And that leaves me with x minus 2y. All right. Back to factoring. Factors of 8 that add to give me 4. All right, we got to think about that. Factors of 8 that add to give me 4. So I know the factor pairs of 8 are 8 and 1 and 4 and 2. And none of them add to give me 4. 8 plus 1 is 9, and 4 plus 2 is 6. So none of them give me 4, so this is prime. Okay. All right, 55. I'm going to have to probably, 4. So this is a factor by grouping. So we're going to group the first two. and the last two, we're going to put an addition sign in between. GCF of 25x cubed and 75x squared is 25x squared, and that leaves me with just an x minus 3. Alright, and so I'm hoping when I factor out my -9 here that I'm going to get x plus 3 minus 3. There we go. And then I factor out my x minus 3, and I write what's left, 25x squared minus 9. And there are my two binomials. Oh, this is a little hidden one. 25x squared minus 9. This is the difference of two squares, so we can get another factor. This becomes 5x minus 3 and 5x plus 3. There we go, difference of squares. So yeah, you might have to keep an eye out for that. Factor then solve, so this is going to be a zero product property in a second. Factors of 56 that subtract to give me 15. So I know a few things here. I know that the signs are different. Okay, and factors of 56 that subtract to give me 15. Let's see here. 8 times 7 is 56. Okay, but 8 and 7 adds to 15, but it's not subtract, so that's not the answer we're looking for. 8 is 2 times 2 times 2 times 7, so 14, I could do 21 minus 2. There's got to be an answer here. 14 and 4 is not 15. 8 and 7. I got to think about this, and I don't have a lot of time, so I'm going to pause it, think about it. Alright, so yeah, I am going to guess that this is prime. Not guess, this is prime. I'm going to guess that we probably should have had that. Factors of 56 that add to give me 15. I just want to show you another zero product property problem. And I got a little bit of time, so we're going to do it. So we are going to say that this is plus, so both these signs are negative. We're going to do 8 and 7 for 56. And that means we're all set. We factored, we set them both equal to 0, and we're going to get, again, kind of a cheat there. Add 8 to both sides. X equals 8. Add 7. X equals 7. So those would be my two answers if this was plus. This is minus, so technically this is prime. But I did want to show you another zero product property. Alright, a couple minutes to finish up the last two. 196w squared minus 81z squared. 196 is a perfect square, so is w squared, so is 81, so is z squared. This is a difference of two perfect squares. The square root of 196 is 14. Square root of w squared is w. And then plus 9z. And remember, there is no middle term here, so that means the minus is our other one. So 14w plus 9 plus minus plus, it's C is our answer there. And then the last one, factoring. Factors of 42 that add to give me 13. Oh, I got another one down there too. M plus M plus. Factors of 42 that add to give me, we already had this one, 13. That's 6 and 7. So we are done there. And then the last one, again, we could use the shortcut. I think I'll FOIL this one. I used the shortcut last time, and I got a minute and 15 seconds, so I should be able to do that. R squared plus N. Negative 2 times negative 2 is 4. R squared times R squared is R to the 4th. So that's my first. My outer is negative 2 R squared N. R squared N. My inner is negative 2 R squared N. And my last is positive N squared. Combine your like terms. 4R to the 4th minus 4R squared N plus N squared is our answer to that one. I hope this review helped you, and have a good day. I'll see you guys next time.